Hey everyone, today we are going to build a WhatsApp style voice message player with waveform visualization, draggable seeking and speed control. So let's take a look at it in action. Hey everyone, today we are going to build a WhatsApp style voice with waveform visualization, draggable seeking and speed control. Draggable seeking and speed control. So let's take a look at it. Hey everyone, today we are going to build a WhatsApp style voice message player with waveform visualization, draggable seeking and speed control. So let's take a look at it. I have already set up a basic Angular app with version 20. So in this version, the Angular team has updated their style guide, which includes file name and class name suffix optional, meaning we will no longer have component suffix. It's just app.ts. You can read more about it here. And if you want to enable suffix generation, you can do so by adding this in angular.json. I'll add this blog link in the description. Coming back to our code, you can use Angular 17 or above to follow this video. So let's start by creating a new component called voice message player. Right click on app folder and open it in integrated terminal and type in nggc voice message player. Before we begin the voice message player, let's add some basic global styles in style.css. First, we apply box sizing border box to everything using the universal selector. For HTML and body, let's reset the default margin and padding. Body will take full viewport width and height. For font family, I like Roboto. You can get this from Google Fonts. And you need to add this import here. If you want the exact same import, I will add this in the video description. Now let's go to our voice message player component. So here first we define our inputs for the audio source and message type. Either sent or received. Default will be received. And we'll use signal to track states like whether the audio is loaded or if it's playing. Now let's create our UI. We will start with the container div for the entire voice message. We need a dynamic class. It's bound to message type signal. So we can style it differently based on whether it's sent or received message. Next, we need an audio element to handle the actual playback. We need a template reference variable audio element. So we can control this tag from the component later. The source will be audio source. Now we need to add a container for the visible player. This will hold the play button, waveform, time display and speed controls. Inside that, let's add a play pause button. It gets disabled until the audio is fully loaded. If it's paused, we will show only play icon, else pause icon. Next, we need a container for the waveform. This section will hold the bars that represent the audio visually and the time labels. Inside that, we place a wrapper for both the waveform bars and the playback progress thumb. And here is the progress thumb. Below waveform wrapper, we need a time display section. This is for current playback time starting at 0, and this is for total duration. For now, these are static values. We'll bind them later. Next, we need to add playback speed. We'll just display 1x for now. And that's it. We have a basic structure now. Let's add our component selector in app.html so that when we start applying the styles, we'll be able to see the UI updates right away. Copy the component name and add it in imports. We don't need this. Now let's center the component on the page. We will target the host element. Now let's do ng-serve. Okay, we can start applying the styles now. And for the styles, let's start with the main container. This wraps the entire voice message and handles the background and shape. We are giving it a light gray background, some rounded corners, a little padding inside, and a vertical margin to space it out. For voice player, we'll give display flex. Items are aligned in the center and give some spacing between them. Next, for the play pause button, let's give a WhatsApp like green color. No border and a circular shape. Width and height are set to 36 pixels. Use flex here to center the icon inside the button. We did not add that yet, so let's add the icon. Go to the Google Fonts. Go to the icons. Search for play. Let's toggle this fill switch. I'll change this to rounded. Let's click on this icon and copy the SVG from here. Looks like we made a little mistake here. This should actually be placed inside the button. I'll change this fill to none. Move this to next line, and here next line. Yeah, so let's add fill current color. This is in camel case. We need the pause icon, so let's search that. Copy it, paste it here. Change this to none. add the current color here as well. Now let's go back to styling. Text color is white. It's clickable. Flex shrink 0 prevents it from squeezing on small screens. We need a slightly darker green on hover, so smooths out the color transition. And when the button is disabled, maybe while loading, we create out and disable pointer events. Next, waveform container. Inside that we have waveform wrapper and time display. For wrapper, let's use position relative so that the thumb can be absolutely positioned over it. Cursor pointer, display flex, align item center, padding will be 8 and 0. Inside bars, we will have waveform bar, which we did not added in our HTML yet. Display flex, align item center, justify content center, 1 pixel gap between each bars with 100%. Each individual bar is 3 pixels wide, light gray background by default, slightly rounded, and has a minimum height. The actual height will vary depending on the waveform data. When the bar has plate class, we change its color to green, representing progress. For the thumb, position will be absolute, width 12, height 12, background 25D366, border 2 pixel solid white, border radius 50%, cursor grab, box shadow 0, 1, 3, RGBA 0, 0, 0 and 0.3. Transform translate text minus 50%. This will send the thumb over the first bar. We also add smooth transition for movement and interaction. On hover or while dragging, the thumb should be bigger, so width 16, height 16 pixels, box shadow 0, 2px 6, RGBA 0, 0, 0 and 0.4. And when dragging, it should switch to grabbing cursor. For time display, let's give display flex, justify content space between, font size 11 pixels, color will be light gray. After that we have speed button. It will be a simple pill shaped control. No background, border 1px solid, has triple D, border radius 12 pixels, padding 4 and 8, font size 11, cursor pointer, color hash 666, min width 32 pixels. Now we can add custom styles when the message type is sent. So let's give a different background color for this container, play pause button, waveform bars, and this progress thumb. So we need to replicate the nested structure first. So let's do that. For when the message type is sent, the background color will be hash TCF8C6. For play pause button, background will be hash 128C7E. For waveform bars, background can be P8D4A8. When it's played, 128C7A. The background for progress thumb is 128C7A. You can change these background colors as per your own liking. Now that we have added styles, let's just do the functional part. We need to implement both on init and after view init. We'll use ng onInit lifecycle hook to trigger placeholder waveform generation. Let's define a method to simulate waveform data using random values. We'll use array.from to create an array of 50 numbers. Each number is randomly generated between 8 and 20. This will simulate the visual heights of our waveform bars. Let's declare a variable waveform data. Set the placeholder value to waveform data. Now we can loop through waveform data here. Inside this, we render a div element for each waveform bar. We can set the height in pixels based on the value of each bar in the array. Let's save it and see how it looks. Okay, it looks good. Let's move on. Inside after view init, we need to initialize the web audio API. This ensures the DOM is fully ready before we interact with any media elements. We'll wrap it in a try catch to handle situations where web audio is not supported. This .audio context equals to new window.audio context. If not, we fall back to WebKit audio context. Let's open console to make sure there are no errors. The audio element has a loaded metadata event. This fires when the browser has loaded basic metadata about the audio, like its duration, etc. Let's access the audio element with this template reference. We'll use Angular's signal-based viewchild to reference our audio element. In onloaded metadata, the first thing we need is to get a reference to the native audio element. Using this, we can get the duration of the audio file. So let's declare a variable duration. Now we can set the duration. If for some reason the duration is undefined, we fall back to 0. Finally, we mark the audio as loaded by setting isLoaded to true. Once the audio is loaded, we can play it. So let's add a click event to the button. Inside this, first we need to grab the native audio element. If it's playing, we pause the audio, otherwise we start playing it. Finally, we toggle the playback state by flipping its value. Okay, the button is disabled because we did not pass any audio, so let's do that. So you might want to load your audio files from an external blob storage or a cloud service. But for this demo, I'm going to keep things simple and use a local audio file from our project's public folder. Let's save this and see. Hey everyone, today we are going to build a WhatsApp style voice message player with waveform visualization, trackable seeking and okay, it works. Alright, so right now we just have a placeholder waveform showing up here. What we want is to actually display the real waveform for our audio file and also make sure the progress bar moves as the audio plays. The audio element has another event, can play through. This event fires when the browser determines it can play the audio all the way through without buffering. When that happens, we call analyze audio data. This is where we'll decode the audio and generate a waveform from real audio content. Let's make it as an asynchronous function since we'll be working with promise while fetching and decoding the audio file. If audio context or audio source are missing, we fall back to generating a random placeholder waveform and exit early. We set a flag is analyzing to true to track when the waveform analysis is in progress. Inside try block, we fetch the actual audio file. If the response is not successful, we throw an error with the status. This lets us catch broken URLs or permissions issues. We then convert the response into an array buffer, which is a raw binary representation of the audio file required for decoding. Next, we need to pass the buffer to decode audio data. Const audio buffer equals to await audio context dot decode audio data. This decodes the audio into samples that we can analyze. Then we need to extract channel data, sample rate and duration from that audio buffer. Next, we can calculate samples per bar. Const samples per bar equals to math.floor channel data.length divided by 50. Instead of hard coding, let's declare a variable. We might need that later. This tells us how many audio samples to include in each bar. Let's reset waveform data to start building our new waveform. Now we can loop through each bar and define its start and end sample index in the channel data. This gives us a slice of waveform for that specific bar. Next, we need to calculate root mean square for this segment. For that, initialize two variables, sum to calculate root mean square and max amplitude in case we want peak normalization later. Now we can loop over each sample in the segment and calculate the squared amplitude for RMS and track the highest peak. Once we have passed a segment, we can calculate the RMS value. This will give us a good approximation of the audio's loudness in this segment. Next, we normalize the RMS to a usable visual range. To prevent bars from being too small or too tall, we clamp the final height between 6 and 28 pixels. Now we can add the final bar height to our waveform data. In the catch block, we log any decoding or network errors. And finally, no matter what happens, we reset isAnalyzing to false to mark that analysis is completed. Okay, since this is an async method, this should be promise. Hey everyone, today we are going to build a WhatsApp style voice message player with waveform visualization. There is another event time update. This fires continuously as the audio plays, giving us real-time updates on current time. We can use this to reflect playback progress on the waveform. Here, first thing we need is to check if the user is dragging, so we won't override their interaction with the live updates. If we are not dragging, we get the native audio element. If audio exists, we can update the progress. To keep our code clean and focused, let's move the progress update logic into its own separate method. First, ensure the audio has a valid duration. We need a variable for the progress percentage. This represents how many of the waveform bars should be visually marked as played based on the current progress percentage. This holds the current playback position of the audio. Progress percentage will be current time divided by duration. Next, we need to update played bars. We will get the played bars count by multiplying the progress percentage by the total number of bars. Now we can call this here and this one here. To use the current time here, we need to get the value from audio. Similarly, we have another event called ended, which fires when the audio finishes playing. First, we set is playing to false, then we reset all progress related values to 0, percentage 0, played bars 0, and current time will be 0. If you want, you can set progress percentage to 100 and show all waveform bars as played when it's finished playing. But in this case, we are choosing to reset everything instead. Now we can apply the paused class conditionally based on the current playback progress. If the index is less than played bars count, the bar will be marked as played. For the progress thumb, if we set the left percentage with progress percentage, it will move the thumb across the waveform as the audio plays. Let's bind the dragging class as well. Let's save this and see. Hey everyone, today we are going to build a WhatsApp style voice message player with waveform visualization, draggable seeking and speed control. So let's take a look at it in action. When the audio ended, it resets everything. Let's comment this and uncomment this and save. Hey everyone, today we are going to build a WhatsApp style voice message player with waveform visualization, draggable seeking and speed control. So let's take a look at it in action. If you prefer this, that's totally fine, but personally I like to reset everything when it's ended. Next step is to update both the current time and the duration as the audio plays. For that, we need a method formatTime that takes a time and returns formatted time as a string. If the time is not a number or less than 0, we just return 0 as a safe fallback. Minutes will be time divided by 60 and seconds will be time mod 60. Then return minutes seconds dot toString dot pad start to 0. If it's less than 10, we add a leading 0. Now let's replace hard-coded value in the HTML. Format time of current time and here format time of duration. Hey everyone, today we are going to build a WhatsApp style voice message player with waveform visualization. Okay, it's working. As we play the audio, both the time and duration are getting updated. Now let's add playback speed functionality. On click of this, we'll toggle the speed. To do this, we'll need a list of available playback speeds and a variable to keep track of the current speed index. Playback rates equals to 1, 1.25, 1.5 and 2. Current rate index will be 0. Going back to here, this dot current rate index equals to this dot current rate index plus 1 modulo this dot playback rates dot length. So what this code does is, every time the user clicks to change the speed, we increment the current rate index by 1. But to make sure we loop back to the beginning after reaching the end of our playback rates array, we use the modulo operator. So if we have 4 speeds like 1, 1.25, 1.5 and 2, this line will cycle through them in order, and when we reach the last one, it wraps around and starts again from the beginning. Let's create a signal to store the playback rate and show it in UI. Now we can update the playback rate to the new selected rate. The next important step is to actually change the speed of the audio playback itself. First, we need to get the current audio element by calling this dot audio element. If the audio element and its native DOM element exists, we need to set the playback rate property to whatever value is currently stored in our playback rate. Now we can change the hard-coded value here. Let's save this and see. Hey everyone, today we are going to build a WhatsApp style voice message player with waveform visualization, draggable seeking and speed control. So let's take a look at it. Next, when the user clicks on the waveform or drags the progress thumb, we want two things to happen. The played portion of the waveform should update visually. Second, the audio should start playing from that new position. First, we need a template reference variable waveform wrapper so we can measure its width when needed. Next, we need a click event. Mouse down to start the drag. Mouse move to update the thumb position while dragging. Mouse up to end the drag. And mouse leave in case the user moves their cursor out of the waveform area. Let's set up all four methods for handling user interaction with our waveform. If the audio is not loaded or currently analyzing, we simply return. Next, we need to get the bounding box of the waveform so we can calculate where exactly the click happened. Const rect equals to waveform wrapper dot native element dot get bounding client rect. Then we need to know how far across the waveform the user has clicked. Const clientX equals to event.clientX minus rect.left. Const percentage equals to clientX by rect.width into 100. Let's create a private method for progress update logic that takes percentage. Like before, we need to get the reference of the audio element. Then we convert that percentage into actual seconds based on the audio's total duration. This new time value we calculated can be directly set as our current time. To re-render the played bars, we can call update played bars. Now we can call set progress here. For start dragging as well, just like before, if the audio is not loaded or currently analyzing, we simply return. Then we set is dragging to true. Then event.prevent default. Next, while dragging, we check if that drag flag is active. If not, we ignore the event. Next, we need to calculate exactly how far the user has dragged across the waveform so we can update the progress and playback position accordingly. Let me quickly type out the logic for this and then I'll walk you through how it works. First, we get the bounding rectangle of the waveform wrapper to know its position and size. Then we calculate how far the mouse has moved from the left edge of the waveform. Then we convert that distance into a percentage of the waveform width, making sure it stays between 0 and 100. Finally, we set the progress percentage and update the played bars. On mouse up or mouse leave, like before, if the drag is not active, we ignore it. Then we set is dragging to false. And we need to call set progress. Let's save and test this. File voice message player with waveform visualization drag to build a WhatsApp style voice message control. So let's take a look at it. So yeah, it's working. Let's also try different message type and see how it looks. And that's it. We have a fully interactive voice message player. You can click or drag to seek, change playback speed with a smooth UI.